Welcome to this introductory video for the course Kinematics of Mechanisms and Machines. My name is Anirban Dasgupta. I am from the Department of Mechanical Engineering at IIT Kharagpur. You must have heard these terms mechanization and automation. You are familiar with these terms. Let us begin by looking at some of the areas where mechanization and automation are of importance. Manufacturing. You know, the manufacturing process itself requires lot of automation and mechanization. Welding, assembly, painting, packaging, these are mostly nowadays done by very special machines which are fully automatic or by robots which are programmed. Nowadays a lot of mechanization and automation has entered the area of healthcare. Surgery, especially telesurgery, is being performed. People are trying to use robots for performing surgery when the surgeon is sitting at a distance, maybe across continents. This will require lot of automation, lot of mechanization in the surgery process. You will require special tools which can be used in telesurgery. Then prosthetics, exoskeletons. You require these exoskeletons for helping a person with possibly disabilities or to enhance the capability of a person in lifting, let us say, loads or performing activities which will require a lot of force. So, this will require the study of mechanisms which will go into that exoskeleton. When the arm is being bent, I mean the exoskeleton should assist this bending of this arm, and it is not a simple hinge in various kinds of joints that we have. Therefore, we need to understand the kinematics of these exoskeletal devices as well as the kinematics of the human body. Then we have these transfer devices for old patients or people with disabilities. There are devices which can take a person from lying down position to sitting position and from sitting position to standing position. These devices have mechanisms, they require mechanisms which are actuated by motors or other kinds of actuators which help a person to perform these kinds of simple tasks. In mechanical handling, you know that machine loading, unloading, these processes are nowadays in a number of industries, they are being done automatically through robots or other special purpose machines. In automotive and aerospace industries, there is lot of automation and mechanization. For example, bus doors. Bus doors, earlier days the bus doors used to open, this was a simple hinge, either single door which used to open as a single hinge. But nowadays an automatic bus door is no longer a single hinge kind of a thing, it moves kind of parallelly and opens like this, or it slides. Now, these are driven by mechanisms. There are mechanisms which work in such devices. And wipers, you must have seen in old cars, the wipers are just a hinge. I mean the wiper just wipes the screen in moving in a circular path about a particular center. But in modern cars, they have a 4-bar mechanism. They have a mechanism which helps it to wipe a larger area with the same motion. Then there are simulators in aircraft, for aircrafts and even for buses and cars. So driving simulators, these driving simulators are nothing but mechanisms, spatial mechanisms, and the kind of motion that you give to simulate, let us say, falling in an air pocket or taking off or landing, these will require lot of motion planning for such for such devices. So, construction of these devices, analysis of velocity, acceleration are very important for such devices. Now, every mechanization or automation of a work process will require a mechanical operation. For example, this mechanical operation could be as simple as opening a door, or it could be as complicated as motion planning of a driving simulator, or maybe machining on a very complicated 3-dimensional contour. So, this operation has to be studied. This operation will require understanding this mechanical operation will require the understanding of motion or displacement of, let us say, the end effector or the output of a mechanism. Then you require path generation. For example, you need a robot to pick a certain workpiece and load it onto a machine in a certain manner, or maybe use or pick a product from a conveyor line and package it. So, all this will require motion planning, path planning. So, typically in robots you require motion planning in order to guide a certain the end effector or a product through a certain path and take it to a certain point. All this automation and mechanization involves transformation of motion. For example, from a rotary motion you might require a translatory motion or an oscillatory motion. So, what kind of mechanism you will use for this purpose? What will be the displacement relation? What will be the velocity relation or acceleration relation? So, these are the things that we need to study. Then transformation of forces. You have a motor which produces a very small torque, but you need to drive something which requires a higher torque. How do you transform forces using gearboxes? So, these are things that we are going to discuss. Our domain of study is linkage mechanism. So, these are closed chain mechanisms, which you also have open chain mechanisms which come under robots, of course, but under linkage mechanism we will be studying about the kinematics of closed chain mechanisms. Robots, both closed chain and open chain. Nowadays robots are not just open chain manipulators, but also parallel manipulators which are closed chain robots. So, we are going to discuss robots which are both open chain and closed chain. So, the kinematics of these systems, velocity analysis, acceleration analysis, etc. We are also going to discuss about geared transmission. As I was mentioning, you need to enhance torque or reduce speed of rotation. We use geared transmission. We are going to look at manual transmission and automatic transmission, and all this will involve not only motion, but also force, analysis of force transmission. So, finally, I welcome you to this course, and I hope that this course will be useful to you.